We covered the exact values before when we went over summer homework, but our homework next time is going to be based on the exact values in degree measure, as we'll see in the next set of videos for the following class day. We leave degrees behind forever and we pick up radians, and we'll do this same process in radians. But for now, we're going to do it in degrees, and as I told you, it is an excellent idea that you are able to start with a blank piece of paper, draw a unit circle in the XY plane, and be able to fill out the entire unit circle on your own with no help whatsoever. So that's what I'm going to do now with angle measures in degrees, and then we will revisit it for the next lesson and we will do it in radians. Remember, this is 0 degrees and 360 degrees, one full revolution. The exact value angle measures that we are interested in from standard position are 30 degrees, 45 degrees, and 60 degrees in quadrant 1. Remember, in quadrant 1 we have positive x coordinates and positive y coordinates to all points in the plane. We are interested in the points on the surface of the unit circle. Remember, unit means 1. We have a radius everywhere here in this circle of 1. Because of that, we can go back to, we understand the sine of theta is the ratio of the opposite over the hypotenuse. When we solve that for y, our y coordinate to every point in the plane on the surface of a circle of radius r is that radius times the sine of theta. When r is 1, the y coordinate to every point is the sine of the angle measure at that point. In like fashion, since the cosine is adjacent over hypotenuse, the x coordinate is the length of the radius times the cosine of that angle measure. Since we are in the unit circle and the radius is 1, the x coordinate winds up being the cosine of that angle measure. There are only 3 values that we are going to have to worry about unless we're at a quadrantal angle. The only 3 values are 1/2, root 2 over 2, and root 3 over 2 in numerical order from least to greatest. We remember that at 45 degrees, there's only one of those values attached to both sine and cosine. Depending on which quadrant we're in, then we worry about whether it is a negative or positive sine or cosine. This is quadrant 3 down here. There's quadrant 4, and we recognize we have positive x coordinates and negative y coordinates in that quadrant. Again, all of this information we have already covered. So when we talk about 30 degrees and 60 degrees, we know we really only have those 2 values to be concerned with. I told you that to this day, the way that I remember whether cosine is 1/2 or root 3 over 2 is based on the length of the x side of the right triangle in question. It's either root 3 over 2 or 1/2. I know when my angle measure is 30 degrees, my x coordinate is greater than my y coordinate in the point on the surface of the circle. Since root 3 over 2 is greater than 1/2, that means the cosine of 30 degrees has to be the bigger of those two values. Here in the 60-degree angle, since the x-coordinate has to be smaller than the y-coordinate, I know that the cosine of 60 degrees has to be the smaller of those two values. So there we are. That is what I am going to use to fill in the entire unit circle. That's really, besides the quadrantal angles, remember the quadrantal angles lie on the axes, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. But we also know there's a radius of 1, there's a radius of 1, radius of 1, radius of 1. So we know the coordinates of those quadrantal angles. So I'm going to clear this, and we are going to fill out the unit circle in degrees. I'm going to put the angle measure just right here inside. This is 0 degrees. I'll put 360 degrees outside. There's 90 degrees. And in each quadrant, we have 3 angles on the interior that are going to be exact value angle measures. So that's what I'm doing for each quadrant there. And I'm interested in the coordinates of these points on the surface of this unit circle. Because as I just explained, the x-coordinate to all these points is the cosine of the angle measure at that point. And the y-coordinate is the sine of the angle measure at that point. These are the exact values. Of course, they're in degrees, but you're going to be responsible for knowing them in radians. So let's figure out how we're going to figure out what our angle measures are. Well, in every quadrant in the unit circle, we have 30 degrees and 60 degrees. We start at 0, there's 30, 60, 90. So that means we have 2. I'm skipping 45 degrees. He'll be another 45 degree one. So if I just count 30 degrees for every 1/3 of every quadrant and add it to the previous degree measure, that should be an accurate degree measure for that angle. So 90 degrees plus 30 degrees is 120 degrees. 120 degrees plus 30 degrees is 150 degrees. 150 plus 30 is 180. 180 plus 30 is 210. 210 plus 30 is 240. 240 plus 30 is 270. Another 30 is 300. Another 30 is 330. And another 30 is 360. So it's not as difficult as you might think. And we'll do the same type of thing when we change from degrees to radians. So now we have 45 degrees. Notice in each quadrant there are only 2 45-degree angles. 45 plus 45 is 90. Plus another 45 is 135. Plus another 45 is 180. Plus another 45 is 225. 45 is 270. Another 45 is 315. And the final 45 gets us back to 360. So there is all of the angle measures in degrees for the entire unit circle. Now we need to fill out the exact values. We'll start with the quadrantal angles because we know the coordinates of those points. There's 1 unit to the right of the point of origin along the x-axis and 0 units up. The coordinates of that point are 1, 0. The coordinates at 90 degrees are 0, 1. The coordinates at 180 degrees are -1, 0. And at 270 degrees, they are 0, -1. Again, we know the x-coordinate to these points is the cosine of that angle measure. This is how we're going to find the cosine of 180 degrees. We know the cosine of 180 degrees has to be -1. The sine of 0 degrees has to be 0. The sine of 270 degrees has to be -1. The cosine of 90 degrees has to be 0. Now we're going to fill out the angles that are in each quadrant. We will start with the 45-degree angle and its reference angles around the unit circle. Again, all we have to pay attention to is the SIGN sign that's happening on each coordinate in each particular quadrant. This we brought with us from algebra. So that we know to be true. We know that this has to be a -√2/2 and a +√2/2. So the cosine of 135 degrees is -√2/2. The sine of 135 degrees must be +√2/2. In the same vein, we will fill out the other reference angles in quadrant 3 and quadrant 4.